Hello, this is a video about proving angle relationships. In the previous unit, we identified and used special pairs of angles. Now we're going to write proofs involving supplementary and complementary angles, and write proofs involving congruent and right angles. Before we get started on the proofs, we have a couple of postulates to show you. We have the protractor postulate, and it says given any angle, the measure can be put into one-to-one correspondence with real numbers between 0 and 180. Basically, it's saying as long as you line this up with a 0, you can measure an angle anywhere between 0 and 180 degrees. We also have the angle addition postulate. If D is in the interior of angle ABC, then the measure of angle ABD plus the measure of angle BDBC equals the measure of the angle ABC. So basically we have the measurement of two small angles that are adjacent, add them together, and it equals the measurement of the bigger angle. Here's an example of how the angle addition postulate works. So we're going to find the measure of angle 1 if the measure of angle 2 is 58 and the measure of the angle JKL is 162. So basically we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle JKL. So we can call our angle 1 x plus 58 is equal to 162. So then when we subtract 58 from both sides of our equation, we end up with x equals 104. Therefore, the measure of angle 1 is 104 degrees. Okay, so now we have a couple of more theorems. This one is the supplement theorem. It says if two angles form a linear pair, then they are supplementary angles. The proof of this is really a simple proof. Basically, if you have a linear pair, this is the picture that you have. And so because of the protractor postulate, or because of the angle addition postulate, we can say angle 1 plus angle 2 is equal to all the angles on one side of the line, which is 180 degrees from the protractor postulate. The complement theorem is another theorem that we have. If the non-common sides of two adjacent angles form a right angle, then we know that the right angle is 90 degrees. So therefore, because of the angle addition postulate, angle 1 plus angle 2 will equal the 90 degrees. And that's the definition of complementary. When we introduced the algebraic properties for real numbers, we had 3 of them that also worked with congruence. So we had the reflexive property. So if the measure of angle 1 equals the measure of angle 1, if it's the same on both sides, then on both sides of the congruent symbol, then we know that it's reflexive. The symmetric property of congruence, we had the if A is equal to B, then B is equal to A. And so it's the same thing with congruence properties. So if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. You're allowed to switch the order. The transitive property says if the measure of angle 1 is congruent to the measure of angle 2 and the angle 2 is congruent to angle 3, then we know that angle 1 is also congruent to angle 3. So right down here I have the proof of the symmetric property congruence, and all of these are similar to that. This one is basically saying that if you're given angle A is congruent to angle B, then B is congruent to angle A. And so the way that we prove that is, we've been using two-column proofs, but this one is a paragraph proof. It just basically says if you're given A is congruent to angle B, by the definition of congruent angles, the measures are equal. And if you use the symmetric property of equality, then we can switch the order and say that measure of angle B is equal to the measure of angle A. Thus, the angle B is congruent to angle A because of the definition of congruent angles. So it's a really simple proof. These are two very similar theorems. We have the congruent supplements theorem that says angles supplementary to the same angle or to congruent angles are congruent. We abbreviate it just by using some symbols. Angles supplement to the same angle or congruent angles are congruent. It's saying that if angle 1 and angle 2 are supplementary and angle 3 and angle 2 are also supplementary, then angles 1 and 3 both have to be congruent. And this one is the congruent complements theorem. It basically says the same thing, only we're talking complementary. If 4 and 5 are complementary, then and 5 and 6 are complementary, then 4 and 6 have to be congruent. The proof of that is here on this slide. Actually, this is just the proof of the congruence theorem. So if we are given that angle 1 and angle 2 are supplementary and angle 2 and angle 3 are supplementary, we want to prove that 3 and 1 are congruent. So we write down our given, and then we have given as our first reason. The definition of supplementary is that the angles at measures added together equal 180. So we have that. That's a definition of supplementary angles. Then since they both of these sum of angles are both equal to 180, we can set those equal to each other. That's by substitution. And we know that angle 2 on this side and angle 2 on this side are equal to each other, so that's a reflexive property. If I subtract both of these from one from each side, then I end up with angle 1. The measure of angle 1 is equal to the measure of angle 3. So it's subtracting, and therefore they are congruent angles, and that's the definition of congruent angles. We have already talked about this theorem, the vertical angles theorem. I mentioned to you that the two angles that are vertical are congruent. And so the way we prove that pretty much is using the supplements to the same angle are congruent, because 1 and 2 are supplementary, 2 and 3 are supplementary, and so 1 and 3 have to be equal. Same with the other pair. All of these right angle theorems basically are saying that, okay, let's look at them. Perpendicular lines intersect to form 4 right angles. So if I know that these are perpendicular, then I know that this is a right angle. And that means all of these would be right angles, because these ones are vertical angles. These are vertical angles, okay? All right angles are congruent. That's a big one. So if you know that that's a right angle and that's a right angle, then you know these are equal. Perpendicular lines form congruent adjacent angles. Well, if these are congruent, they're also adjacent, so that's what's happening. They are forming congruent adjacent angles. If two angles are congruent and supplementary, they're congruent and they add up to 180, then they are right angles. The only way is to make two angles equal 180, divide that by 2, so the angle has to be 90. If two congruent angles form a linear pair, then they are right angles. So if we have these two being a linear pair, which means they're supplementary, which follows on this